Hello, I'm Anil Rao, responsible for security and systems architecture in the Intel Data Platforms group. I'm excited to be here today to give you a preview of the new security features that are coming in the third generation Intel Xeon Scalable processor. I don't need to tell you that security is important, but let's look at what's driving the need. As the world becomes more connected, we are seeing an exponential growth in data. Now, in order to process this data, new types of computing opportunities such as cloud, edge, artificial intelligence, various types of analytics are emerging and transforming the way in which business operations are happening in the infrastructure. But those transformations can drive complexities for IT, especially when you start going from cloud to edge, that could increase risks to business if security is not properly addressed. So, security must go hand in hand with some of these business transformations. Now let's talk about a few trends that are emerging in the security landscape. Now, these trends are enabling us at Intel in leading the way in establishing a trusted computing foundation. Encrypt everything throughout the life cycle, from data generation to data retirement, is something that is vital and a key thing. There is also an emerging infrastructure capability where workloads and data need to be isolated. This workload and data isolation is something that is a new trend, and we'll talk about it a little more later. On top of some of these trends, building a chain of trust that is fundamentally rooted in silicon is an important capability, and we'll talk about some of those as well. Now, all of these capabilities that are coming up in the infrastructure today can help with compliance, can help with policy, and can help our customers meet and even go better than the policies and regulations that are generally put on infrastructure operations. Now, one of the most important things to think about is how security is only as good as the layer below it. Let's talk about this a little bit. You can have the most secure application in the world, but if the operating system or the hypervisor that application is running on is compromised, it can spoof that application into thinking that everything is okay. And the security of the software layer does not matter if the underlying operating system and the hypervisor is compromised. Now, as the security in the software layers, the higher level layers, continues to improve, attackers are increasingly moving down the stack in order to look for new vulnerabilities. Now, this is exactly why you need to start with security at the lowest layer possible. And for us, that lowest layer is the silicon layer. Once you build security at the lowest layer in the silicon, then you can build solutions on top of it and create a trusted foundation for applications to operate. At Intel, we're focused on protecting the data throughout its life cycle. We're helping protecting the platform by establishing a chain of trust that is resilient against compromise. And we're accelerating some of the cryptographic functions in order to help ensure that you as an end user and a customer don't have to sacrifice between performance and implementing security. Now, I would like to start drilling into one of these areas in particular, because the other ones, especially on the data storage, we have long understood that data should be encrypted when it is stored. We've also known that you should encrypt data when it is sent across a network. Both of those are things that we've known, and technologies have been something that we've built over a period of time. But what about when the data is actively being processed in memory? Especially in the world today where systems are typically shared, whether it is internally or in a cloud, and whether it is operated by your own IT and infrastructure operators or it's in a third-party cloud, you need to make sure that when these systems are shared, it is important to protect data as it's actively being processed in memory. Doing this is where we are creating and driving a new frontier, and this new frontier is creating what we call data in use confidentiality, and we'll talk more about it as well. Now, application data and even the code itself is almost always under attack. Now, gone are the days when we can rely on just perimeter defenses alone in order to keep information and IP safe. Attackers can be hackers from external worlds, unauthorized third parties, or even malicious insiders who can go in and get visibility to data where they shouldn't be getting visibility to this information. And they can leverage exploits in other applications as well, or create privileged escalations in operating systems or in hypervisor layers. What we need in order to attack and address these things is a multi-layered defense-in-depth strategy in order to make it cost-prohibitive to execute a successful attack on the code, whether it is being stored, whether it is in flight, or whether it is under use. Intel Software Guard Extensions, or SGX, is designed to provide a critical layer in that defense-to-depth technology that we already spoke about. SGX is already available in Xeon E processors, and it's deployed in production solutions today. Intel SGX is the most researched, updated, and battle-tested trusted execution environment available in the data center. It is constructed to have the smallest potential attack surface within the entire system. This enables applications to communicate directly with the CPU and the encrypted memory, bypassing the operating system and hypervisor layers. This means that it is designed not to expose any of the SGX protected code and data, even in the event of a breach in those layers, because even at the privilege level that the operating systems and the hypervisors operate in, they don't have access to the data in the SGX encrypted memory. This is why I'm pleased to announce that we are bringing the Intel SGX to our full line of upcoming third generation Xeon scalable processors, also codenamed Ice Lake. And even better, along with bringing these capabilities into Ice Lake, we are now including up to 1 terabyte of available protected enclave space in order to accommodate huge workloads that we tend to see in data center operations. Now, this technology comes with capabilities for protected offload, where you can offload directly from the enclaves to hardware in order to accommodate huge workloads that can then run or operate on FPGAs or GPU accelerators. And the Intel SGX ecosystem is ballooning to accommodate solutions across the spectrum of these computational models. Now, IT leaders and developers have a multitude of options in order to adopt security into their infrastructure. And with Intel SGX technology, they have options. And they have options in how to take and address their security and confidentiality needs using the Intel SGX enclaves. Applications can be developed or refactored utilizing a broad range of open source SDKs, and some of those are listed on this slide here, and solutions, and placing the most control in the hands of these application developers or the owners of the data. So you can go very fine granularity in terms of how you use the Intel SGX SDK in order to develop and control security into those applications. Or there are some new lift and shift capabilities that are emerging from our partners and from the open source community in order to enable unmodified applications to run within such an enclave or a container. So this provides our customers and even code developers and deployers multitude of options in such a way they can choose one or the other in order to ensure that their applications are safe and their applications are running in a confidential and secure manner. Now, in order to enable any of these capabilities, creating an open source and an ecosystem in order to drive innovation in software and ecosystems is very important. And this is why we helped create and found the Confidential Compute Consortium. The goal of the Confidential Compute Consortium is to work within an open source community to accelerate the awareness and adoption of confidential computing. As you can see with the who's who on the list here, there is a growing number of members who are prominent and are trusted contributors in this space. And all of us are working and collaborating together in order to bring a committed ecosystem of both customers, developers, and partners in order to ease the use and ease the portability of applications in a confidential computing environment in order to help all the developers and IT professionals to adopt the new emerging technologies that is essentially needed in the data center industry. Now, I want to talk a little bit more about some of the usages. And confidential computing, especially some of the technologies that we're driving with our customers and partners in the industry, makes a whole host of new usages possible. It's not just about what was there before and protecting simple things. It's kind of like expanding the horizon of what we can do. Now, some are things like expanded capabilities for managing and protecting encrypted keys, database records, even virtual network functions with general purpose Xeon type of like hardware. But in the area of multi-party computing, an emerging field these days, new doors will be opened with technologies of this particular nature. Now let's look at some of this. Imagine being able to spread machine learning across sources, across multiple parties, while still keeping the algorithm and data sets private and confidentiality. Or by providing the ability to migrate extremely sensitive data to the cloud while maintaining privacy, security, and not breaching any regulatory environments or regulatory requirements. Now, this is essentially something that SGX as a technology and confidential computing is intended to do, and it is starting to do it already. We've talked a lot about Intel SGX, but it's far from the only innovation that we're introducing in our Ice Lake processors. Let me talk about another one, which is called the Total Memory Encryption. We're also making Total Memory Encryption in order to enable customers to encrypt memory of the complete address space, or encrypt the full memory address space. Now, think of this as a bit locker for your system memory. It can provide extra protections, especially against rare but very important physical attacks, such as memory freezing or memory removal. Now, the beauty of this total memory encryption is that it's completely transparent to operating systems or even software layers. It does not require any type of like enabling. It does not require anything in terms of changes to the application infrastructure. So it's very, very easy to deploy this particular capability where you go and encrypt the total memory, and anything associated with memory-related operations are not visible to anyone because it's completely encrypted. We'll talk more about some of the additional capabilities that we're bringing in, and you will see that over a period of time, as I talk about all of these capabilities, we're raising the bar further in establishing trusted and foundational security in our platforms and infrastructure. Now, this feature called the Platform Firmware Resiliency, or the Intel PFR, is one of the critical pieces in order to drive trusted platform foundation. As some of you may know, NIST has defined a standard for firmware resiliency, and we're seeing the industry rally around this capability. Intel is very happy to be contributing to options in this space with an Intel FPGA-based solution that can provide multiple capabilities. First, it can help validate critical to boot platform firmware components before they end up in the execution mode. And then, if any of them are found to be corrupted, it can automatically recover the firmware back to a known gold or a good state, reducing the risk of downtime and reduce the risk of any permanent denial of service attacks that can potentially happen. And lastly, the Intel PFR feature continues to monitor and filter all the system buses for malicious traffic. It monitors and makes sure that it helps any further reduction in any type of attacks that can potentially happen on the system. Now, together, this PFR and some of the capabilities that we have forms what we call a platform root of trust that gives server manufacturers a pre-validated solution that can help protect this critical platform layer that is so vital to security and foundational security operations. We've been to so many customers and so many IT operators, and we know that performance is critical. And in various symposiums and technology seminars, performance is often cited as a reason why IT managers don't more fully implement these security measures. We know it is imperative that security solutions must still enable performant workloads. We don't want to be between performance and security. In the Intel Xeon Scalable platforms, we continue to add new hardware accelerators coupled with the innovations in software that deliver breakthrough performance for the industry's most widely adopted crypto algorithms. As an example, we've accelerated certain RSA algorithms by nearly 8x and reduced the cost of AES computations in terms of cycles per byte in our Xeon Ice Lake. With these kinds of hardware accelerations built into the Ice Lake technology, you don't need to trade off security and performance. And this, I think, is very, very important for a lot of software and IT managers so that they can continue to get the performance that they need without compromising on security. Data and technology sit at the root of modern business transformation. We've spoken about security, and we know and we all believe that security must advance hand in hand in order to make this business transformation possible. And rooting security solutions in hardware is the best way to help ensure a trusted foundation and a chain of trust. We at Intel, we have committed to putting security first. With all the new features and capabilities, I think you'll agree that Intel's third generation Xeon Scalable processor is a revolutionary step forward in delivering on this security promise. Thank you very much.